What if I told you that one simple graph could help you predict equipment failures before they happen? It's called a box plot. Box plots are powerful tools used to analyze data in predictive maintenance. In this video, I'll show you how box plots can help you detect anomalies, spot trends, and make data-driven decisions that keep your machines running longer. Imagine knowing when your car needs an oil change before it breaks down. That's the power of predictive maintenance. We use data and cool tools to predict when machines need some love and care. Predictive maintenance is like having a crystal ball for your machines. It helps us avoid costly downtime and keeps things running smoothly. It's like knowing when your bicycle chain needs some grease before it starts to rust. By using data, we can make smart decisions about maintenance and keep everything in tip-top shape. So how do we do this magical predictive maintenance? Well, we use all sorts of data like temperature readings, vibration patterns, and even sound recordings. It's like listening to your machine's heartbeat. And one of the coolest tools we use to understand this data is called a box plot. When analyzing machine health, raw data can be overwhelming. We need a way to summarize large data sets while keeping critical insights visible. That's where box plots come in. They provide a snapshot of performance trends, showing normal operation, variability, and potential outliers that could signal trouble. Today, we'll cover what a box plot is and how it works, how to use box plots to monitor equipment performance, real-world examples of box plots in predictive maintenance. Box plots provide snapshots of a process over time. They show you how your machine's data is spread out. Imagine you're tracking how much your plant grows every day. A box plot would show you the average growth, the highest and lowest growth, and everything in between. Now, let's break down a box plot. It's like a sandwich. A box plot, also known as a whisker plot, is a simple yet powerful way to visualize data distribution. It consists of 6 key elements: Q1, Q2, Q3, IQR, whiskers, and outliers. The first quartile, Q1, the value below which 25% of the data falls. Q1 represents the lowest recorded value, excluding outliers. This value is called the minimum. The median, also called Q2 or second quartile, is the middle value of your data. The box around the median shows you where the middle 50% of your data lies. The third quartile, Q3. The value below which 75% of the data falls is called the maximum, the highest recorded value, excluding outliers. The lines extending from the box are like whiskers, showing the range of your data. Sometimes you'll see little dots outside the whiskers. Those extreme points outside the normal range are called outliers. Outliers occur when your data exhibits abnormal behavior, like when your plant suddenly grows twice as much as usual. Outliers can be signs of trouble, so we pay attention to them. In predictive maintenance, these outliers could be early warning signs of impending failures. Box plots help us see patterns and spot potential problems before they become big headaches. Now, here's where it gets really cool. We can use box plots to travel through time with our machine's data. By creating box plots for different time periods, we can see how our machine's behavior changes over time. Think of it like comparing your plant's growth in the spring versus the summer. The box plots would show you how the growth patterns differ. Similarly, we can use box plots to compare our machine's performance from last month to this month, or even last year to this year. This helps us spot trends and identify potential problems early on. For example, if we see the median vibration level slowly creeping up over time, it could be a sign of wear and tear. We can then schedule maintenance before the problem gets worse. It's like giving your machine a checkup before it gets sick. How box plots help in predictive maintenance? Box plots are essential for monitoring critical machine parameters like vibration levels, temperature fluctuations, and pressure variations. Here's how they help. Identifying normal versus abnormal behavior. By tracking a machine's historical data, we can establish a normal operating range. If a new data point falls outside this range, especially in the outlier zone, it signals potential issues. Detecting trends over time. A single box plot gives us a snapshot, but comparing box plots over time reveals trends. If the median starts shifting upwards or the interquartile range expands, it may indicate worsening conditions. Spotting sudden failures versus gradual deterioration, a sudden spike in outliers, that might be a sudden failure or an anomaly, a gradually increasing median. That's an early sign of wear and tear that needs attention before it escalates. We use Boxplots to help identify impending failures. For example, bearing wear over time shows gradual wear progression with increasing vibration levels over time. Bearing misalignment over time displays a steeper increase in vibration levels, suggesting worsening misalignment. Motor unbalance. Over time, a steady increase in vibration, indicating worsening balance issues in the motor. Motor looseness. Over time, a sudden jump in vibration levels in May and June, signifying severe looseness leading to failure. Imagine you're monitoring the vibration levels of a motor. Initially, the box plot shows a consistent range with only minor fluctuations, but over time, the median begins shifting upwards and outliers start appearing more frequently. This indicates increasing wear on the bearings, allowing maintenance teams to intervene before a breakdown occurs. Now consider monitoring temperature in a hydraulic system. The lifetime of a filter can be expressed by a box plot time series plot. 1. Newly installed filter. 2. Filter midlife. And 3. Filter burp, where the clogged filter releases into the ambient. This would be indicated by an overheating issue due to a clogged filter. By analyzing these patterns, box plots help maintenance teams act before failures occur, reducing downtime and saving costs. To get the most out of box plots, avoid these common pitfalls. Ignoring small but consistent outliers. Repeated outliers might indicate a slow-growing issue, not comparing box plots over time. A single box plot is useful, but historical comparison is where the true insights come from. Failing to investigate high variability, if the interquartile range keeps growing, your process might be losing control. Box plots are like superheroes in the world of predictive maintenance. They help us make sense of complex data and keep our machines running smoothly. Imagine a giant wind turbine spinning gracefully in the wind. We can use box plots to monitor the vibration levels of the blades. If we see a sudden increase in vibration or any outliers, it could mean there's a problem with the blades. This allows us to schedule maintenance before the problem gets worse, preventing costly downtime and ensuring the turbine keeps generating clean energy. Box plots are one of the simplest yet most effective tools for predictive maintenance. By identifying anomalies, tracking trends, and detecting early warning signs, they allow us to prevent costly failures before they happen. Box plots are amazing tools that help us make sense of data and keep our machines happy and healthy. It's all about using data to make smart decisions and predict the future. Now it's your turn. Have you used box plots in maintenance or reliability analysis? Let me know in the comments below. Don't forget to like, subscribe, and hit the notification bell for more insights on predictive maintenance and reliability engineering. Thanks for watching.